This is page 184. Read along with me. Marta, Lori Beth, and Ira all have bicycles. The table shows the number of miles of each rider's last bike ride, as well as the time it took each rider to complete the ride. Number 16 reads, what is Marta's unit rate in minutes per mile? And I want you to recognize here that they tell you how to set this up. They tell you to put the minutes over the miles. Minutes per mile means the minutes over the miles. So we're going to go get her minutes. We're going to put that over miles. And her minutes is 80, and her miles were 8. So it's going to be 80 over 8. And what are we supposed to do here? It says right here we need to find the unit rate. And unit rate means to simplify to where your second term is 1. So if we divide by 8, our second term will be 1, and it's going to be 1 mile. We knew that from over here. And if we simplify the first one by 8, 80 divided by 8 is 10. It's going to be 10 minutes. So her rate is 10 minutes per mile. So I'm going to write that on the line. What is Marta's unit rate in minutes per mile? It's 10 minutes. I need to make a little space here. It's going to be 10 minutes per mile. And one way to write that is to write 10 minutes and then put a slash and then put a mile. You could use the word per, or you can use that slash. So what I just wrote there is 10 minutes per mile. Okay? All right, so let's go ahead and move forward. And the next question reads, I'm on question 17, says, whose speed was the fastest on their last bike ride? So what we knew so far about Marta is that she can go 10 minutes per 1 mile. Now we're going to do the same thing with the other two. Laura Beth can go, I'm going to show my work down here. Laura Beth can go, it takes her 42 minutes to go 6 miles. And I'm going to simplify those by 6. And I get 7 minutes per 1 mile. I'm going to go ahead and write that up here. She can go 7 minutes per mile. 7 minutes per 1 mile. Now I'm going to do Ira. I can do Ira's down below. Ira's going to be 75 minutes for 15 miles. Multiplication chart here tells me that 15 and 75 share a factor of 15, so I'll simplify by 15. And 75 divided by 15 is 5 minutes. And 15 divided by 15 is 1 mile. So I'm going to write in Ira's information. Ira's can do 5 minutes per mile. Now be careful when you answer this question about choosing. A lot of kids want to choose Marta because it's the biggest number. But I want you to recognize what these numbers are saying. We're talking about how many minutes it takes them to do a mile. Minutes per mile means that it takes Marta 10 minutes to do a mile, and it only takes Ira 5 minutes to do a mile. Well, if you're racing, you want to try and get done with the mile faster. So the faster person is the one with the lowest number here. Ira's the fastest because 5 minutes per mile is faster than 10 minutes in 1 mile. 10 minutes for 1 mile. So they go the same distance, but it only takes Ira 5 minutes. So Ira is going the fastest. A lot of kids are going to put Marta there because it's the biggest number, but it's actually backwards. All right, so let's check out number 18. Number 18 is quite tricky, but I can help you. I think I'm going to try to show my work over here on the right. It says, if all 3 riders travel for 3.5 hours at the same speed as their last ride, how many total miles will the 3 riders travel together? So let's think about one person at a time. Let's think about Marta. Marta can go, maybe I might need to use my lines here to show all my work. Marta can go 10 minutes per mile. So she can go 1 mile in 10 minutes. So 10 minutes for 1 mile. And what this says is she's going to travel for 3.5 hours. So the first thing we need to do is figure out how many minutes is 3.5 hours. And the reason why I need to change it to minutes is because all the information we have so far is in minutes, and they're asking us a question in hours. So what I'm going to do here is I'm going to figure out how many minutes is 3.5 hours. And we could pretty much do that mentally. Every hour is worth 60 minutes. So I'm going to do 60 plus 60 plus 60. That's going to be 180. And then I have another half an hour, and half an hour is 30 minutes, so I'm going to add up 30 minutes to that. So how many minutes is this? It's 210 minutes. So this question right here basically says if all 3 riders travel for I'm going to change it to 210 minutes. Now I have some compatible numbers. Now what I know is this. For Marta, it takes her 10 minutes to go a mile. How far can she go in 210 minutes? So if we think about it we could set up a ratio like this. 10 minutes, this is for Marta only, 10 minutes for 1 mile is going to be equal to 210 minutes for how many miles? I don't know. Well, how many times does 10 go into 210? It's going to be 21. So if you multiply that by 21, you're going to multiply this by 21, and you're going to get 21 miles. So Marta can go 21 miles in 210 minutes. Now I have to do the same thing with all the other kids, except it's going to be a little bit different math, because the next kid was, Laura Beth can go 7 minutes for 1 mile. It takes her 7 minutes to do 1 mile. Well, how do I get from 7 up to 210? I multiply by 30. 7 times 3 is 21, and x is 0 makes 210. So if you multiply one term by 30, you have to multiply the other term by 30. And so what do you get? You get 30 miles for Laura Beth. So on my line here, I'm going to write Laura Beth is 7 minutes per mile. And what I'm going to do is write that equals 30 miles. I just showed my work on the side. And I've got one more kid to do, and that's going to be Ira. Ira can go 5 minutes per mile. Do you remember doing that a minute ago? And now I need to simply multiply 5 by something to get 210. Well, 5 times 20 is 100. 5 times 40 will be 200. So it's going to be 5 times 42. And I can double check that here by going 210 divided by 5 is 42. So if you multiply one term by 42, you have to multiply the other term by 42. And so it's going to be 42 miles for Ira. Now that should make sense. Ira can go the farthest because Ira is going the fastest. It only takes Ira 5 minutes to do a mile. So how far can Ira go in 210 minutes? 42 miles. Now the question doesn't actually ask you to do all that. The question asks you to say, how far can they all go combined? It says all together. So we're going to add up 21 and 30 and 42. We're going to get 3 and 7, and I get 93. 93 total miles. Now, I told you that one would be tricky, and I'm sorry that it was, but we have to do the hard problems sometimes. So good job for sticking with me. If you do want some further explanation on that, please let me know. All right, let's check out the next problem. Number 19 reads, Jason watched a caterpillar move 10 feet in 2 minutes. Jason says the caterpillar's unit rate is 0.2 feet per minute. Is Jason correct? I want you to pay attention to the fact that they tell you to do feet per minute. What that means is that feet go over minutes, and the feet in this problem were 10 feet, and the minutes were 2 minutes, and if you simplify by 2, you would get 5 over 1, 5 feet per 1 minute. So that's the answer. It says, is Jason correct? No. And it says explain. I'm going to say the rate is 5 feet per 1 minute. And if you wanted to explain further, if you haven't noticed this yet, what did Jason do? He set it up upside down. He put the 2 over the 10. And 2 divided by 10 is 0.2. But then he would have been calculating the minutes per feet, not the feet per minute. So he kind of did, he got the words in the right order, but the numbers in the wrong order. So the words determine the order of the numbers. Okay, we are out of time for this video. I'm going to allow you to, for this lesson, I'm going to allow you to skip the hot problems because we're out of time. Good job. You're done with page 184.